Welcome everyone, I'm Saleha Javed and today we are going to talk about search in reasoning and retrieval. So the contents we are going to cover are, first we will go through solving problems by searching, and we will cover some uninformed blind search strategies. We will go through what is breadth first and what is depth first algorithm. Then we will move on to informed heuristic search strategies and we will see what is A-star algorithm. So solving problem by searching, in which we see how an agent can find a sequence of actions that achieves its goal when no single action will do. So problem solving agents use atomic representation where there is no internal structure visible. So it's a black box which is performing actions, but we know how it is performing. And goal-based agents or planning agents use more advanced structural representations. So how the problem is represented? So as you see in front of you, there's a different set of nodes with different edges in between. So we have an initial state from which we start our searching problem, and let's say here that S is an initial state. Then we have a set of applicable actions. By taking that action, we move on to next state from our initial state. Let's say that arrow or edge is how we traverse from one state to another one. Then we have a transition model, and through which we reached our goal state, which let's say is G. And while we are traversing or going from one node or to another one, we have a certain path cost or step cost that we have to cover in order to conduct our action. And here the target is that we have to derive certain action sequence from initial to goal state in a way that the solution is of good quality. And we define how we are setting the quality parameter here. For instance, in this example, we say that the path cost function should have the lowest value, and if we have the lowest value, our solution is of good quality. So that is how our problem is designed. And we have different solutions or different algorithms to perform and solve certain problems. In uninformed blind searches, we have breadth first search, uniform cost, depth first, depth limited, iterative deepening depth first, and bidirectional. And in informed searches, we have best first or greedy search algorithm and A-star. So let's see what are uninformed or blind searches. So here we have no prior domain knowledge. Basically it examines each node till the goal node is achieved without having any single prior knowledge about the search space. So breadth first search, what it does? So it starts from the root node, expands all the successor nodes at the current level of the depth before moving to the next level. And depth first search, it performs its search in a way that it starts from the root node S, explore as far as possible the depth. Let's see in detail how their action is basically performed. So why they are called blind search? Suppose you are in a labyrinth, you start at node S, you want to reach goal G, and where do we go? We have no idea how to reach G goal. But we can have smart guessing. And how? We start from the graph which we have as a search space and in a problem definition, and we formulate it into a tree. As you see on the other side, we have imitated those loops or circles from the graph and transformed it into a tree structure on which we can perform our search algorithm. Now starting from how breadth first search works. So as a problem definition has the information that we start from the initial state S. So the first arrow which you see going on to the next node A is the first action of breadth first search algorithm. Now how it decides which node it should discover next. So as breadth first search covers all these successors which are on the same level or the adjacent nodes which are on the same level. So it moves on to node B or state B. Then it has no node on that same level, so it moves on to one level down, C node, and then it covers all the nodes in that level, which is D, G and H, and those are covered as they come across in the queue list. From H, it moves down one level again and discovers E. It again checks, have I reached my goal state? No. Or depth? No. Then it covers the other successors in this on the same level, and from there it discovers the last node, which is here K, and finishes the search. However, depth first search, it starts its search the same manner as breadth first search, that is, from starting initial state S, it moves on to A, which was one level down. Then it keeps on going down level by level until it reaches a depth. Now, instead of going to B like in breadth first search, it moves to the node C. From there, it moves to node E, and then finally the end of the depth, which is node K. And now you see the difference between breadth first search and depth first search. So, you can see the traverse path or the search space path of breadth first search within a different manner. So, all the nodes on the same level are discovered one time, and then the next whole level is discovered. However, in depth first search, it focuses on the depth, starts from the initial state and reaches deep down to the depth, and then it covers the another depth later on. So, if we compare them and see which one is performing better than the other, then we will see that breadth first search will provide a solution, if any. As you saw, it covers all the successors of one level, and the chances of it finding a solution are more likely than depth first search. How? Because depth first search has no guarantee that it will find a solution. And breadth first search, if there are more than one solution for a given problem, it will provide the optimal solution with the least number of steps. However, depth first search might get trapped in infinite loop. Breadth first search requires lot of memory, since each level of the tree must be saved into the memory to expand the next level. This is one bigger con of breadth first search, because depth first search requires very less memory, as it only needs to store the stack of the nodes on the one path, which is from root node or the initial node to the current node. Breadth first search needs lots of time if the solution is far away from the root node, because it has to cover all the nodes in each of the levels. However, depth first search needs less time to reach the goal node if it traverses the right path. If you are on the wrong path, then you can end up in infinite loop, or you can end up computing or consuming a lot of computational power. Breadth first search needs less time to reach the goal node if the goal is close. However, depth first search could miss the goal node and then need a lot of time, then might end up in a long path. So, these were the uninformed searches. That's it for today. Thank you.